Alright, y'all, this is the review for the Unit 6 test. Number 1, evaluate the factorial expression. So as a reminder, the way the factorials work is you're multiplying by every integer below that number. So 7 factorial is the same thing as 7 times 6 times 5 times 4, etc., all the way down to 1. But instead of writing all that out, I don't want pink, I'm going to say 7 times 6 times 5 factorial, because it would keep going on forever and ever. And the reason I chose to stop at 5 is so that I can cancel those out. And then I'm just left with 7 times 6, which is easy enough. My answer is 42. Number 2 is very similar. I've got 12 factorial over 6 factorial, 6 factorial. I'm going to go ahead and try to cancel out one of those 6's. So 12 times 11 times 10 times 9 times 8 times 7 times 6 factorial over 6 factorial, 6 factorial. We'll cancel out one of the 6's. So what I'm left with now is 12 times 11 times 10 times 9 times 8 times 7 over 6 times 5 times 4 times 3 times 2 times 1, but multiplying something by 1 doesn't change its value, so I don't actually have to write that. So you are welcome to put that entire thing into your calculator. I think I'm going to do a little simplifying first. Like, for instance, I know 6 times 2 is 12, so that 12 with that 12 can cancel out. I know 8 divided by 4 is 2. I know 9 divided by 3 is 3, and 10 divided by 5 is 2. Again, you don't have to do this simplifying stuff. It just, I don't know, it makes my life easier. I think it would make your life easier too. So that's all I'm going to put in my calculator. 11 times 2 times 3 times 2 times 7. 11 times, oh no. No. Calculate. 11 times 2 times 3 times 2 times 7 gives me an answer. Oh my gosh, this glitchy board. 3 times, there we go, 924. Cool. Number 3, we're still evaluating factorials. The same rules apply even if I'm looking at variables. So even though there is n, the same ideas still apply. I'm multiplying by 1 less every time. So if I'm looking at the denominator and I see n plus 1 factorial and I want to write this out, I know that I would multiply by 1 less, by 1 less, by 1 less, all the way down to 1. So what is 1 less than n plus 1? Well, that would just be n. So I could rewrite the denominator, the n plus 1 factorial, as n plus 1 times n factorial, which works out well because I can cancel those out. Leaves me with 1 over n plus 1. No more simplifying I can do. That's my answer. Number 4, evaluate the factorial expression. I'm going to do something very similar. I see that the denominator is bigger, so I'm going to expand that out. So n times n plus 6 factorial over n plus 7 n plus 6 factorial. Those n plus 6 factorials cancel out. Leaves me with n over n plus 7, which is my simplified answer. That's it. Number 5. Write out the first 5 terms of the sequence. Hold on. Okay, write out the first 5 terms of the sequence. So I've got a formula that has an n in it, and so the way I get my first 5 terms, well, if I want my first term, I'm going to plug in a 1. For my second term, plug in 2. For my third term, plug in 3, etc. So 3 times 1 minus 4 would be negative 1. 3 times 2 minus 4 would be 2. 3 times 3 minus 4 would be 5. 3 times 4 minus 4 would be, what is that? 12 minus 4 is 8? Yeah. So my first 5 terms. Let's do one more. 3 times 5 minus 4 would be 11. So my first 4 terms are negative 1, 2, 5, 8, 11. Same thing on number 6. If I want the first 5 terms, I've got to plug in a 1, 2, 3, 4, and 5. So 2 times 1/2 to the first would be 1/2 to the first is just 1/2 times 2 is 1. 2 times 1/2 to the second. Well, 1/2 to the second power, 1/2 times 1/2 is 1/4. 1/4 times 2 would be 2/4, which is 1/2. Then 2 times 1/2 to the third. So 1/2 to the third means 1/2 times 1/2 times 1/2 would be 1/8. 1/8 times 2 is 2/8, which would simplify to 1/4. As a reminder, if you don't just love doing all this math in your head, this is a calculator test. You are welcome to check any of these powers, exponents, multiplying in your calculator. 1/2 to the fourth would be 1/16 times 2 is 2/16, which simplifies to 1/8. And finally, 2 times 1/2 to the fifth. 1/2 to the fifth, was that 2, 4, 8, 16, 32. 1/32 times 2 is 2/32, which simplifies to 1/16. Cool. Number 7. The given pattern continues. Write down the nth term of the sequence suggested by the pattern. Okay, let's figure out what this pattern is. I've got a 15, 28, 41, 54. I am noticing that went up 13. That went up 13. This is adding 13 every time, meaning this is an arithmetic sequence. My formula for an arithmetic sequence is a sub n equals a sub 1 plus d n minus 1, where a sub n is the value I'm looking for. A sub 1 is my first term. In this case, it's 15. D is the common difference. That's how much it goes up each time. So 13 and minus 1. And we'll simplify a little bit. I think I'll distribute that 13. 15 plus 13n minus 13. Combine like terms. 2 plus 13n. That would be my formula for finding the nth term of this sequence. Okay, same thing for number 8. I'm trying to figure out how to get from 18 to 11 to 4 to -3. I can see that is subtracting 7 every time. So if it's adding or subtracting the same number every single time, it's still an arithmetic sequence. I'm still going to use this formula right here. So a sub n equals, in this case, a sub 1 is 18, because that's our first term in this sequence, minus, since we're going down every time, 7 n minus 1. Let's simplify. 18 minus 7n plus 7, combine like terms, 25 minus 7n. Okay, the sequence is defined recursively. Write the first 4 terms. Well, the first term's easy because it just told us. First term is 3 because a sub 1 is 3. Now to find my second term, I'm going to use this formula, this one right here, but I'm going to plug in a 2 for n since I want the second term. So a sub 2 equals 3, a sub 2 minus 1 plus 1. Okay, well if I simplify, 2 minus 1 is 1. A sub 1, that's the answer it gave us here at the beginning. That was 3. So instead of a sub 1, I'm going to put 3. 3 times 3 plus 1, which would be 10. Okay, let's find our third term. A sub 3 equals 3 a sub 3 minus 1 plus 1, which would be 3 a sub 2 plus 1. A sub 2, that's the answer I just found. So 10 is what I'm going to plug in for a sub 2, which gives me my answer of 31. And then finally for a sub 4, again I'm just going to use that same formula. 4 minus 1 plus 1. So that's a sub 3. A sub 3, that's the answer I just found. That's 31. So it's 3 times 31 plus 1. That's 93 plus 1. That's 94. Yeah, remember the way these recursive formulas work, you're always going to use the last answer, the answer that you just found. So let's try another one. Let's do number 10. The sequence is defined recursively. Write down the first 4 terms. And a sub 1 is given to us. In our recursive formula, the first term will always be given to you. A sub 2, because I'm looking for the second term, is 2. A sub 2 minus 1 minus 3. If I simplify 2, a sub 1 minus 3, a sub 1 is 2. So 2 times 2 minus 3, which is 1. Okay, third term, a sub 3 equals 2. A sub 3 minus 1 minus 3. 2, a sub 2 minus 3. 2 times, what is a sub 2? A sub 2 is 1. Minus 3. 2 minus 3, negative 1. One more, a sub 4 would be 2. A sub 4 minus 1 minus 3. A sub 3 minus 3. A sub 3 is negative 1. 2 times negative 1 minus 3. That's negative 2 minus 3. Negative 5. Cool. One page down. Come on. There we go. All right, find the indicated term using the given information. Well, if I see D, I know this is going to be an arithmetic sequence. So my formula for finding a given term is that same one I was using on the front page. A sub n equals a sub 1 plus d n minus 1. Now let's plug in what we want. We're looking for a sub 12. A sub 1, well, a with nothing written has an implied 1. So a sub 1 is negative 2. D is 2. And if I'm looking a sub 12, I'm looking for the 12th term, so I'm going to plug in 12 for n. Now I just got to evaluate. Negative 2 plus 2 times 11. Negative 2 plus 22, which gives me an answer of 20. Okay, same thing over here. I'm looking for a particular term. It tells me D, it tells me the difference, which means this is arithmetic, so I'm going to use that same formula. So a sub 9 equals a sub 1, which is 6, plus D, which is 1/2. I'm looking for the 9th term, so 9 for n minus 1. Which goes 6 plus 1/2 times 8. 6 plus 4, so our answer is 10. Okay, number 13, find the 12th term of the arithmetic sequence. This is basically the same thing that we were just doing, it's just written a little bit differently. I have an arithmetic sequence, which means there's an A, there's a common difference, and I'm looking for the 12th term. So I'm looking for a sub 12, since I'm looking for the 12th term. And a sub 1, that's my first term. In this case, it's 6. Plus, well, actually, so remember, our common difference is how much is being added or subtracted each time. In this sequence, in 6, 3, 0, we are subtracting 3 every time. So my difference is actually a negative 3, and then 12 minus 1, since I'm looking for the 12th term. So 6 minus 3 times 11. 6 minus 33, which would be negative 27. Okay, number 14, find the 10th term of the arithmetic sequence. Same kind of thing. Here we go. A sub 10 equals a sub 1 is 2, that's my first term. D is 5 because it's adding 5 every time. 10 minus 1. 2 plus 5 times 9. 2 plus 45, 47. All right, a theater has 25 rows with 30 seats in the first row, 34 seats in the second row, 38 seats in the third row, and so forth. How many seats are in the theater? So this one's going to be different because I'm wanting to know the number in the entire theater, which means this is going to be a sum question. So my sum formula is the S sub n equals n over 2 a sub 1 plus a sub n, where n is the number of terms I have, a sub 1 is the value of my first term, a sub n is the value of my last term. So we've got enough information to go ahead and start plugging things in. How many terms are there? Well, there are 25 rows, so n would be 25. A sub 1 is my first term. There are 30 seats in the first row, so we'll start with 30. And a sub n is, what is a sub n? Oh no, we don't know a sub n. A sub n would be how many seats are in the last row, and we don't know that. So we got to figure that out. We're going to figure that out, come on, by using our other formula. I want to know how many rows are in the 25th row. So I'm looking for a sub 25, and I'm going to use that same formula I just used on the last problem. A sub 1 is 30. Let's see, the first row has 30, the next one is 34, so we're going up 4 every time. The difference is 4. 25 minus 1. Yeah, so that's 30 plus 4 times 24. So that's 30 plus 96, which would give us 126. Plus 126 seats in the very last row. So S sub n equals 25 over 2 plus 156. You know, I think I'm going to go ahead and use my calculator. My brain's tired. Let's see. 25 divided by 2 times, what was it, 156? Yeah. 156. 1,950 seats in that theater. Number 16, a staircase has 18 steps. The first step requires 300 bricks. The second step requires 288 bricks. The third step requires 276, and so forth. How many bricks are required to build the staircase? So again, I'm wanting to know the answer for the entire staircase, so I'm going to have to use the sum. But as we figured out in this last problem, in order to use that sum formula, I need to know how many terms I have, which I know in this case because there's 18 steps. I need to know the value of my first, which I know how many are in the first, and I need to know how many are in the last. I don't know that. So let's start by using our nth term arithmetic sequence formula to figure out how many are in the last one. I need to know what A18 is, meaning what is the value at the 18th term. So a sub 1 is 300. Our common difference in this case is 12, because it's going down 12 every time, times 12, 18 minus 1. So that's 300 minus 12 times 17. I think I'll use a calculator again. 12 times 17. And then 300 minus that would be 96. So there are 96 bricks in the final step. So let's get the sum of all of them. Let's figure out how many bricks are in the staircase. 18 over 2 times 300 plus 96. So that's what? 9 times 396? That's going to be a big number. 9 times 396 is 3564. 3564 would be our answer. Number 17, find the sum of the arithmetic sequence. So we're still using that sum formula. This time, at least we know our first and our last term, but we don't know how many terms we have. So we're going to have to use this first formula again. So a sub, well, no, I know what the last term is. I'm going to plug in, come on, I want to plug in 313. 313 equals a sub 1, which is our first term, plus our difference, which is 1. It's going up 1 every time, times n minus 1, because I'm trying to figure out 313 is which term. So now I'm going to treat this like an Algebra 1 problem. I'm going to try to figure out what n is. So let's subtract 6 on both sides. 307 equals 1 times n minus 1. Divide by 1 just cancels out. Add 1. 308 equals n. So that is the 308th term. Let's plug it into our formula. The sum of these n terms would be 308 over 2, not equals, parentheses, first term 6 plus last term 313. So that's 154 times 319. Come on, calculator. Oh my gosh. 154 times 319, 49,126. $49,126 is our answer for number 17. Number 18, we gotta do the same thing, same kind of problem. Let's figure out how many terms there are. 100 equals our first term, negative 24. Our common difference is 4. It's going up 4 every time. Plus 4 and minus 1. Let's solve for n. So I'm going to add 24 to both sides. 124 equals 4 n minus 1. Divide by 4. Divide by 4, that's 31. Is that right? Yeah. Equals n minus 1. So n is 32. Alright, let's plug it in. The sum of the terms up through n would be 32 over 2 times negative 24 plus 100. So that's 16 times 76. Let's see what that is. $12.16. That would be our answer for number 18. Number 19, find the sum of the arithmetic sequence. Okay, so I'm looking for the sum. I'm still using that sum formula. S sub n equals n. It just told us what that was. That's nice. Over 2. It didn't tell us our first term or our last term, but it did give us a formula to figure out because it told us the formula. So to figure out our first term, let's plug in a 1. 2 times 1 minus 8, which is 2 minus 8, which is negative 6. And then let's figure out our last term. I know there are 13 terms, so let's plug in a 13 to figure out what our 13th term is. So that's 26 minus 8, which would be 18. So 13 over 2 times 12. And that's 13 times 6. Right? 78. Let's make sure. 13 divided by 2 times 12. Cool. 78. Number 20, same process. Here we go. The sum up through n would be n over 2, so that's 20 over 2. Our first term, negative 3 times 1 plus 1 is negative 2. And our last term, which is our 20th term, would be negative 59. Yeah. So negative 2 minus 59. That's 10 times negative 57. Nope, that's not right. Negative 61. Negative 61. Which would give us an answer of negative 610. Cool. Alright, Determine whether the given sequence is arithmetic, geometric, or neither. If arithmetic, find the common difference. If geometric, find the common ratio. So if you can't just look at this and know what to do, the best thing to do is to go ahead and find the first few terms. That'll make your life a lot easier. So let's do that. Let's plug in a 1. So 3 times 1 to the third would be 3. 3 times 2 to the third, let's see, 2 to the third is 8, times 3 is 24. 3 to the third, 3 to the third to the third, that's 27 times 3, which would be 81. And that's enough. Let's take a look at this. If this was an arithmetic sequence, that means I could add something every time. So to get from here to here, I'd have to add 21. But to get from here to here, 21 would not get me there. So let's figure out what has to be multiplied. 3 times 8 would be 24. 24 times 8 is definitely not 81. So this is neither arithmetic nor geometric. So neither. Number 22, same thing. Let's figure out what it is. You can plug in your first 3 numbers to get your first 3 terms, and that would help you figure it out. You might be able to just look at this formula and know, because I'm seeing that every time n increases, there's going to be another 3 added on, because 3 is multiplied by n, which tells me this is going to be an arithmetic sequence. Arithmetic. And that d, the number that gets added every single time, is 3. Again, if you don't feel confident just looking at that and knowing that, you can always plug in the first 3 terms and figure that out. Number 23, again, we're trying to figure out what's happening. And if I think about what this formula would be doing, I would be taking 1/3 and multiplying it many times depending on which term I'm at. So each time I go up to another term, I'm going to have to multiply another 1/3. So if I'm multiplying every time, this is geometric. And the number I'm multiplying, the ratio, would be 1/3. Okay. 24. Use the formula for the general term, the nth term, of a geometric sequence to find the indicated term of the sequence with the given first term a sub 1 and common ratio. So we've moved on to geometric now. Our formula for finding the nth term of a geometric sequence would be a sub n equals a r to the n minus 1. So I want to find our general term first, meaning I want to keep n there, but I'm going to plug in those other things. So a sub n would be 2 times 6 to the n minus 1. That is my general term in terms of n. Now I want to find a particular value. I want to find a to the 8th. So I'm going to plug in an 8 for n. 2 times 6 to the 8 minus 1. That's going to be a gross number. Let's figure out what that is. 2 times 8 to the, wait, no, it was 6. Times 6 to the 7th. 559,872. 559,872. Cool. A new piece of equipment costs a company $122,000. Each year for tax purposes, the company depreciates the value by 15%. What should the company give the equipment after 10 years? Okay, so this is a geometric sequence because I'm going to be multiplying each time, which means I'm going to be using that formula. My a sub n equals a r to the n minus 1. I'm using this formula because it's geometric and because I'm looking for a particular term. I want to know what happened after 10 years. So let's see if we can figure out what these different variables are going to be in this situation. A, remember, is our first term. That's pretty easy. That's 122,000. R is the number that I would multiply by to get the next term. Well, if I want a formula that tells me how much this piece of equipment is worth, I know I need to use this 15%. I know I need to turn it to a decimal. But if I just multiply by 15% or 0.15, that will only tell me how much it depreciated. I don't want to know how much it depreciated. I want to know how much it is worth. So remember, if something depreciates, it decreases. So to figure out what that would be, I'm just going to take the 100% that it started with, subtract the 15%, which means I'm left with 85% value. So R is going to be 0.85. N is the term I'm looking for. It wants to know what it is after 10 years. Well, if this one right here is my first term, then a year later would be my second term. 2 years later would be my third term, etc., etc. Meaning, if I want to know after 10 years after my first term, that actually puts me at 11. Okay, let's plug things in. 122,000 times 0.85 to the 11 minus 1. 122,000 times 0.85 to the 10th gives me approximately 24,018.7. 24,018.7, is that what it was? And I'm sure this has been rounded, but that's okay. We'll have to round on our test too. Number 26, a small business owner made $50,000 the first year he owned his store and made an additional 5% over the previous year each subsequent year. Find his total earnings during the first 5 years. If I want to know his total earnings in those entire 5 years, I'm not going to use this formula because that formula helped me find one particular number. I don't want one particular number. I want the sum of several numbers put together. So we're going to use our sum formula for the geometric sequence. So that formula would be S sub n equals a sub 1 times 1 minus r to the n over 1 minus r. Alright, so let's see if we can figure out what these variables would be in this situation. So a sub 1 is our first term. Again, that's pretty easy. That's just the 50,000. R would be that common ratio, that number that I multiply by each time to figure out what my next value would be. So he's making 50,000 in his first year, and I want to know how much he made in the next years. Well, he earned an additional 5%. So I need to add that 5% to what he was already making. So if I made that a decimal, that would be 0.05, but I need that plus the 100% of money he already had. 1.05 would be R in this situation. So the sum is 50,000 times 1 minus 1.05 to the, what's n? I want to know his earnings during the first 5 years, and it's 5. 5 over 1 minus 1.05. 50,000 times 1 minus 1.05. 0.05 to the 5th over 1 minus 1.05. Which means over the course of those 5 years, he made about 276,282. Well, that's not bad. 276,282? Is that what it was? Yeah. Okay, now we're on to our binomial stuff, y'all's favorite stuff. Okay, expand the expression using the binomial theorem. So, if we're going to do this, remember the first thing we want to do is use that triangle number. So take a look at your triangle. Go down to the 4th row. What are your coefficients? If I'm at the 4th exponent, I need the 4th row. So that would be 1, 4, 6, 4, 1. Now I know my first term, this x, is going to descend. So it starts at whatever this exponent was. X to the fourth, x to the third, x squared, x to the first, x to the 0. And our second term is going to ascend, starting at 0, 3 to the 0, 3 to the 1, 3 squared, 3 to the third, 3 to the fourth. And let's simplify. So 3 to the 0 is 1, because anything to the 0 is 1. So 1 times x to the fourth is x to the fourth. Plus 3 to the 1 is 3, times 4 is 12. 12x to the third. 3 squared is 9. 9 times 6 is 54. 3 to the third is 27. 27 times 4 is 108. And 3 to the fourth is 81. That would be my simplified expansion of that binomial. Let's do some more. Maybe. Alright, 4x plus 2 to the fifth. Okay, let's find our fifth row of our triangle. Write out our coefficients. 1, 5, 10, 10, 5, 1. Let's take our first term and descend. 4x to the fifth, 4x to the fourth, 4x to the third, 4x squared, 4x to the first, 4x to the 0. Okay, let's take our second term and let's ascend. 2 to the 0, 2 to the 1, 2 squared, 2 to the third, 2 to the fourth, 2 to the fifth. Cool. Let's put some plus signs and let's simplify. So on this first term, 2 to the 0 is 1, so that just kind of disappears. 4 to the fifth, what is that? 4 to the fifth would be 1024. 1024 x to the third plus 4 to the fourth. What was that? 4 to the fourth is 256 times 5 times 2, so times 10, which would be, what is that? Come back, calculator. 2560 x to the fourth plus 4 to the third, that's 64 times 4 times 10, 64 times 4 times 10 was 2560 again. All right. 2560 x to the third. 4 squared is 16. 2 to the third is 8. So 10 times 16 times 8 is 1280. 1280 x squared. 4 to the first is 4. 2 to the fourth is 16. Yeah. So 5 times 4 times 16. 320. And anything to the 0 is 1. 2 to the fifth was at 2, 4, 8, 16, 32. That's our answer for number 28. Okay, number 29. Find the eighth term in the expansion of x plus 4y to the 13th. So you had two options. If you want to expand the entire thing and then look at the eighth term, you can. I don't want to do that. That's gross. I don't have time for that. I'm going to use that formula that helps us find any particular number in Pascal's triangle. That formula was n prime, or n factorial, excuse me, over n minus k factorial, k factorial, where n is the row we're looking for and k is the column. So in this case, n is going to be 13 because n is always the exponent of the binomial that's being expanded. And k would be 7 because it's always one less than the term that you're looking for. So let's plug that in. 13 factorial over 13 minus 7 factorial, 7 factorial. So that's 13 factorial over, what would that be? 6? 6 factorial, 7 factorial, which would be 13 times 12 times 11 times 10 times 9 times 8. I'm going to cancel out those 7s. Over 6 times 5 times 4 times 3 times 2. Again, I don't really have to write that one because anything times 1 is just going to be itself. It's not going to change any values. So I do want to simplify this a little bit because that's already pretty gross. I know that 4 times 3 is 12, so those will cancel out. 5 times 2 is 10, so those will cancel out. Yeah, cool. Let's put that in our calculator. 13, 11, 9, 8. 13 times 11 times 9 times 8 over 6. 17, 16 would be the triangle number at that position. So the way I'm doing things, that's my blue number. That's the number I pulled off of Pascal's triangle. Now, let's descend x. Well, if I know x is going to start to the 13th, x to the 13th is my first term, so 13th, 12th, 11th, 10th, 9th, 8th, 7th, 6th. X to the 6th would be my 8th term. X to the 6th. I also know 4y is going to ascend, so it's going to start at 0, 0, 1, 2, 3, 4, 5, 6, 7. That's going to be 4y to the 7th power. These are going to be some gross numbers, y'all, but that's all right. So we need to do 4 to the 7th times 17, 16. 4 to the 7th times 17, 16. Yep, there it is. 28114944. 28114944. X to the 6th, y to the 7th. And that's my answer. That is my 8th term. Yep, there it is. Okay, let's do another one. Expand the expression using the binomial theorem. So basically it's just saying do that whole thing again. Okay, so third row. Let's go to our third row of our Pascal's triangle and write out our coefficients. 1, 3, 3, 1. Okay, first term is going to descend. X to the 5th, x to the 4th. Oh, hold on. That's a 3. Oh my gosh. X third, x squared, x to the 1st, x to the 0. Second term is going to ascend. -5 to the 0, -5 to the 1, -5 squared, -5 to the 3rd. Plus, plus, plus. Simplify. -5 to the 0 is 1. 1 times 1 times x to the 3rd is x to the 3rd. -5, I always do that. -5 to the 1st is -5. This thing's going to be negative. I'm going to be subtracting. -5 times 3 is -15. So -15 x squared. -5 squared is +25 times 3 is 75 x. And -5 to the 3rd is 125, -125. And x to the 0 is just 1, so it's gone. Cool, that's 30. 2 more, y'all. We got this. Expand the expression using the binomial theorem. Fourth row, Pascal's triangle. 1. Oh, let me change colors. 1, 4, 6, 4, 1. Okay, first term is going to descend. 2x to the fourth, 2x to the third, 2x squared, 2x to the first, 2x to the 0. Second term is going to ascend. Negative 3 to 0, negative 3 to the 1, negative 3 squared, negative 3 to the third, negative 3 to the fourth. All right, let's evaluate. Let's simplify. Negative 3 to the 0 is 1, because anything to the 0 is 1. To the fourth, that's 2, 4, 8, 16. So 16, x to the fourth. 2 to the third is 8. 8 times negative 3 is negative 24 times 4. I don't know. What was it? Negative 24 times 4? Negative 96 minus 96. X to the third. 2 squared is 4. Negative 3 squared is positive 9. So 6 times 4 is 24 times 9. 216. Oh gosh, I always do that. Negative 3 to the third power would be negative 27. Negative 27 times 2 times 4. Oh no. It was negative 216. X. And negative 3 to the fourth would be positive 81. And that's it. Everything else is gone. It's times 1. Cool. That's our answer on 31. Okay, last one. This one's going to be gross. It's going to be alright though. The 10th term in the expansion of 2x minus 3y to the 15th. Remember, if you really wanted, you could totally just try to draw out your triangle and find that number. I don't want to do that. I don't have time to do that. So what I'm going to do is I am going to use that formula to figure things out. So it's going to be 15 factorial over 15 minus 10 factorial, 10 factorial, which simplifies to 15 factorial, 5 factorial, 10 factorial, which would be 15 times 14 times 13 times 12 times 11 over 5 times 4 times 3 times 2. Let's cancel some things out. 5 times 2 is, oh, I don't have a 10. 5 times 3 is 15. 4 times, crud. 12 divided by 2 is 6. That's fine. That was not the best way to do that, but that's okay. So what was that? 14, 13, 6, 11? 14, 13, 6, 11 over 4. 3003. That's the triangle number. 3003 would be what I find if I look that up in the triangle. That is our blue number. Well, it's my blue number because I'm writing that in blue. And, oh, don't do that. Go back. 3003. I know that term 1 is going to descend, so it starts out 2x to the 15th, then it goes down to 14, 13, 12, 11, 10, 9, 8, 7, 6. The 10th term would be 2x. Oh, I didn't change colors. 2x to the 6th. And I know the second one, I can't read it anymore, is going to ascend. So it's negative 3y. It starts at 0. 1, 2, 3, 4, 5, 6, 7, 8, 9. It's going to go up to the 9th. So negative 3y to the 9th power. That's going to be a big number. Okay, let's see what happens. 3003 times 2 to the, was it 6th? Yep. Times negative 3 to the 9th. Remember, anytime that you're doing a negative number to an exponent, always put the negative number in parentheses. Yep, that's the number, all right. 37829 negative 37829 15136. X to the 6th, y to the 9th. That's our awesome answer. That's your review. Good luck!